Dear students, in this lecture, we are going to discuss about pure inductor excited by AC voltage. Pure inductor excited by AC voltage. The inductor is a type of coil. Coil is nothing but inductor which reserves or stores the electrical energy in the form of magnetic field. As we know that inductor always stores the electrical energy in the form of magnetic field when current is flowing through it. Inductor is made up of a wire which is wound in the form of coil. So when the current flowing through the inductor changes with respect to time, that causes EMF is induced according to Faraday's laws of electromagnetic induction. So inductance is measured in Henry and the opposition of flow of current is known as inductive reactance. This is the nature of the inductance property. The opposition of flow of AC current is nothing but inductive reactance, which is denoted by XL. Here we can see the pure inductor is excited by sinusoidal signal, AC voltage. V equals to, let us consider a sinusoidal signal. V equals to small v, instantaneous value V equals to Vm sin omega t is applied across the pure inductor. That can be also written as Vm at an angle 0 degrees. So as a result, alternating current is flowing through, according to Faraday's laws of electromagnetic induction. Alternating current is flowing through the inductance, which induces the EMF in it. The equation is induced EMF E equals to minus L into di by dt, according to Faraday's laws of electromagnetic induction. So the induced EMF is circuit in the equal and opposite to the applied voltage. Hence the equation will become V equals to, the induced EMF is equal and opposite to the voltage, so that V equals to minus E. So in previous equation will become V equals to L into di by dt. V is nothing but applied voltage. So applied voltage equals to reference signal Vm sin omega t equals to L into di by dt. So di equals to, this di equals to, I am deriving the current di equals to Vm by L into sin omega t into dt. So integrating on both sides, to removing the derivative, integrating on both sides, integral di equals to integral Vm by L into sin omega t into dt. So integral 1 di is I, integral di equals to I, we integral Vm by L, this is the constant term. So Vm by L into integral sin at, this it look like integral sin at formula. Integral sin at equals to minus cos at by A, minus cos at by A. So that Vm by omega L into minus cos omega t. So Vm by omega L equals to sin of minus cos theta can be written as sin of theta minus 90. So sin of theta minus 90, sin of omega t minus pi by 2. So Vm by, this equation will become Vm by omega L is nothing but XL. XL is taken as omega L. So Vm by XL into sin of omega t minus pi 2. Omega t minus pi by 2 is nothing but 90 degrees, theta minus 90. So here Vm by XL is taken as Im. So instantaneous value of current flowing through the inductor equals to small I equals to Vm by XL is taken as Im. So Im into sin of omega t minus 90, theta minus 90, omega t minus pi by 2. Whereas V equals to Vm at an angle 0 degrees, reference signal. Whereas current signal equals to, the derived current signal equals to Im into Im is nothing but Vm by XL. Im into sin of omega t minus pi by 2. So where XL is taken as omega L, it is opposition offered to the flow of alternating current by the pure inductor, and it is also called inductive reactance XL. The value of current will be maximum at sin of omega t minus pi by 2, that equals to 1. So Im is taken as Vm by XL. Though substituting the equation in previous equation, substituting the Im is taken as Vm by XL. So I equals to Im of sin of omega t minus pi by 2. This can be also written as Im at an angle minus 90 degrees. Whereas Vm sin omega t can be written as Vm at an angle 0 degrees. Similarly, Im sin of omega t minus 90 can be written as Im at an angle minus 90 degrees. That means the signal is starting from minus 90 degrees, whereas voltage signal is starting from a reference signal, which is always starting from 0 degrees only. So here we can see the voltage graph, voltage signal as well as current signal as well as power signal. So as we know that voltage signal is always taken as a reference signal, which is starting from always 0 to complete one cycle. Will take 0 to 2 pi radians. This blue color curve represents voltage signal. Then current signal, just now we have derived Im at an angle of minus 90 degrees. Here minus 90. The here plus 90, exactly opposite minus 90. So from minus 90 degrees to current signal is starting. Current signal is starting. That means the phase angle between the voltage and current is always 90 degrees. The phase angle between the voltage and current signal is always 90 degrees. After 90 degrees only current signal will be starting. So during the 0 to pi 0 to pi by 2 0 to pi by 2, the voltage signal, the current signal is negative and current voltage signal is positive. The ultimately power signal will be negative, plus into negative during the negative of cycle, negative. So 0 to pi, the voltage signal is positive, current signal is negative. So minus into plus negative, the power signal will be negative. Similarly, from pi by 2 to from pi by 2 to this duration pi by 2 to pi, the voltage signal is positive. The voltage signal, blue color signal, positive, and the current signal is also positive. So positive into positive, positive, the power signal will be positive. Similarly, pi to 3 pi by 2, pi to 3 pi by 2, here the voltage signal is negative. The here the voltage signal is negative and the current signal is positive, so plus into minus, so power signal will be negative. Similarly, from 3 pi by 2 to 2 pi, the voltage signal is negative and current signal is negative into negative, positive. So in this way power signal will be obtained. So we can calculate, here we can calculate instantaneous value of power. As we know that instantaneous value of power P equals to V into I. Small letters. Instantaneous value is always represented by small alphabets only. So P equals to V is nothing but applied signal across the pure inductor, Vm sin omega t. I equals to derived signal, current flowing through the inductor, Im of sin omega t, minus pi by 2, So Vm into Im into sin omega t, sin of omega t, sin of theta minus pi by 2 can be written as cos theta, is nothing but cos omega t. Next further we can multiply and divided by 2, Vm Im by 2 into 2 sin theta into cos theta. 2 sin, it look like 2 sin theta cos theta is nothing but sin 2 theta. So Vm by 2 can be written as root 2 into root 2. So Vm by root 2 into Im by root 2 into sin 2 theta. So the average, this is the instantaneous power. If you calculate the average power will be obtained by integrating the instantaneous power over a cycle. So this function contains sine. So for a full cycle, sine function or sine or cosine will be automatically 0. If you integrate the full cycle, sine or cosine will be 0. So the average power will be 0 for a entire cycle. For a completion of one cycle, for complete one cycle, the average power will be per pure inductor, average power will be 0. The dissipated power in a pure inductor equals to 0. So that in pure inductor current lags voltage by 90 degrees. In pure inductor current lags voltage by 90 degrees. That means the phase angle between voltage and current equals to 90 degrees. Voltage leads current by 90 degrees or current lags voltage by 90 degrees in pure inductor, whereas pure resistor the phase angle between the voltage and current is 0 degrees, whereas a reference signal is taken as Vm at an angle 0 degrees or Vm sin omega t is written as Vm at an angle 0 degrees. In similarly, the derived current signal equals to Im sin omega t. That means that is also written as Im at an angle 0 degrees. In pure resistor, voltage signal as well as current signal both are starting from 0 degrees and terminating at 2 pi radians. Here, whereas pure inductor voltage signal reference signal is taken as Vm at an angle 0 degrees and current signal is taken as Vm at an angle minus 90 degrees. That means the phase angle between voltage and current is 90 degrees. Current lags the voltage by 90 degrees for pure inductor. In next lecture, we will see the pure capacitor excited by AC voltage. Thank you.